Okay, cool. So, so weird. I didn't do anything. I just restarted the app. Great. So let's wait maybe one more minute. I've seen there are like a few more people here. Maybe they will join. So today, I think this one will be much quicker. Here's the plan. I just want to show the February updates, specifically pathfinding, new mobs, new sounds and soundtrack. I hope you actually can hear the soundtrack. Can you actually hear the soundtrack? Just out of curiosity. Okay, so great. And we'll talk a little bit about things that's still in development that I was planning to show this time, but unfortunately I haven't finished them. Just like working on sound with a sound designer took way too much time than I thought. And then I want to go into some code for pathfinding in shaders. I finally figured out how to use, what is it called? Render doc on Windows, and hopefully can show some of the stuff that I wasn't able to show last time. Let's see. Anyway, we'll go to this later. And yeah, thanks everyone for joining. 6 people. All right, I guess let's start. And I'm just gonna launch. Actually, let me just start here. Let me launch the game. Hopefully it's gonna work. And I'm just double checking. Can you hear the sound in the game? Well, let me open this here. Okay, great. And let me make music a little bit quieter. So, as you remember last time I was showing some map, some mobs, but there was almost like no interaction. I was just working on terrain generation, and after that I basically had to rewrite the whole pathfinding, and so that all this like new terrain things will be taken into account when mobs navigate. So if I open, sorry, actually, where is it? It's in Upgrade. So now everything is dynamic. As you see, these like red things are obstacles that mobs can now avoid when they decide how to path. If I destroy them, you can see it's automatically updated. Same thing for all this kind of like a grid tiles. They can, every time I destroy or build them. Yes, it's basically A star. It used to be bi-directional A star, but then I started rewriting it for open world, and you can see this guy's stuck. And it made more sense not to do bi-directional A star and just go back to the very simple A star, because I just discovered in the long term it would be more efficient to make it hierarchical. So imagine this is like one chunk. When this will be properly working open world game, the way this is gonna work, we're gonna split active chunks into islands. Islands is just a connected part of terrain, and then we first find a path through the islands, and then we find path through within each island, and that just makes more sense to implement as a hierarchical A star and not as bidirectional A star. So right now it's a very simple A star, and again I will show how it works. But yeah, the big update is now dynamic. It works with the new terrain system, and every time I place new stuff, it should automatically, as you see, update the navigation grid. So that was the first thing I worked on. The second thing, is the new mobs. Let me turn off the nav grid. So we have 2 new guys. First one is this kind of like a forest spirit. It's basically just like, you know, not very aggressive mobs. They're gonna live in the forest, and they roughly same power as like a normal human. So yeah, they mostly done. I think all the animations now work. I can't show the attack animation for them because I don't have that part of the AI working right now, but you can see they kind of react to damage, and we spawn their kind of like dead bodies when they die, and things like that. And another mob that was around actually since September, but the artist who's working on it finally got time to finish, is this like a hellhound who's stuck in that in the chest. So the hellhound, I don't have a lot of them on the map. Let me just kind of direct it. It's also fully finished. They supposed to be kind of like a much stronger mobs. Oh, and it crashed. They supposed to be much stronger mobs from the same faction as these guys. So it's kind of like an evil faction that corrupts like forests and lands, and they will spawn from something like a portals, and they supposed to be more high level than these dudes. These dudes also now have 2 variants of their head. Let me show you. Where is it? Let me open a sprite real quick. So creature. So now they have another variant with horns. I don't have it in the game, but this is kind of like a little bit more advanced version than the normal one without horns. Yeah, so far we have these 3 mobs, bunch of animals, and the next couple of mobs will be for caves and maybe like first boss in the next couple of months, I guess. It takes a lot of time to make them. What else? Let's see. So now we have new sound and soundtrack. So the soundtrack is something you can hear in the background. This is just like a basic exploration soundtrack. Should be like not very intrusive, so shouldn't really take a lot of players' attention. Just kind of like should work on the atmosphere when you exploring and maybe building a base. This guy grab a lot of ore, and there will be another one for combat and another one for teaser, which are currently in production. So yeah, hope you guys like the soundtrack. And the last one is the new sounds. So we basically just started working. Let me actually restart. It looks like something is really glitchy. We just started working on the proper sounds with a sound designer. So things like, let me showcase them, like steps or like harvesting now properly have proper sounds. So if I start cutting this tree, you can hear actually proper sounds. Then it falls, and then we collect all the planks. Same thing for other things. They all now have their own sounds. And the same thing for the ores and stones. They should also have their own sounds now. So yeah, that took a lot of time to implement because first of all, the old version of the game had like really messy organization of all the sound assets, and when somebody actually started properly working on that, we had to reorganize everything into a bunch of groups like interactables, inventory, like combat, swooshes, all this kind of stuff. And of course, like this is still actively in progress, so we're adding stuff to like, you know, add sounds to hits to different surfaces, and all this kind of stuff will come in the next version. So that required the game to understand, you know, the surface of things that you are hitting, the surface of like where you walking, and all these things. But yeah, so hopefully this sounds a lot better than the, you know, previous versions I was making myself. How many sounds in the game now? So right now maybe like a few dozens. I can probably show you like a spreadsheet where we have it, but oops. But yeah, like a few dozens. If I turn on, yeah, this is a log. Maybe you can see here, but a lot. Also, we decided to add different sounds for player and NPCs. Like player is more kind of like popped, because it should be like, it should be more in focus comparing to NPCs. NPCs like more muted and have slightly different equalizer settings on them. So if you, for example, see how this guy cutting the stone and how I do it, like I sound a lot more popped. Cool. So did you make the music? I don't make the music. I work with somebody who is pretty talented. Actually, two guys who working on this on the soundtrack. So yeah, it took about a month for one of them to make this first soundtrack, and currently they're working on the second one. But I just like pick the references and kind of like overall try to describe what I'm looking for, just to make sure everything matches. But yeah, this was created from scratch specifically for this game. For me, the stream quality is very bad. So how about others? Like, how is the quality for everyone? Stream quality is okay. All right, let me just double check. I'm still recording everything. Cool. So yeah, not a ton of updates. As I said, working on sound and finishing the navigation took most of the time this month, and I was also super busy with my main work. Obviously, like you can see a lot of bugs in the navigation. It doesn't really take into account size of the colliders for all the entities, so they can stuck in obstacles because the path is way too close to the obstacle. Or sometimes the system that assigns where they should navigate to collect some resources isn't really doing a great job of figuring out where to place the marker for them. Thanks. How the flickering works. What do you mean? Sorry, with flickering? Maybe this one is a little bit too aggressive. If you're talking, we cannot hear you. Interesting. You guys cannot hear me? Oh yeah, the other thing now, comparing to the previous system, now some of the caves have roofs, so it doesn't matter how bright is outside. The inside of this cave, as you can see, it's dark. It's very janky right now, but it's definitely better than it used to be. So if I place a torch, I can make this one a little brighter here. When you're walking around, there's a miner on the bottom, and then when you hear rocks, there was the sparks of something that lights up. Oh yeah, so we just basically spawn light every time we hit the rock. So I can even show you how it works. Again, I'm always really sorry for the code I have to show. It's really ugly because the game is still in high like in experimentation phase. I'm not like worried too much about cleaning this up. But essentially, if I look into, so you see there's a lot of stuff that's just hard-coded here. If I see light source 2D, so yeah, we just spawn a light source at the same place where we spawn some effect. That's basically how it works, and then it's there for 70 milliseconds. So if I make it, let's say not 0.7, if I make it 10, this should look like a nuclear bomb. Let me see. Huh. Nope, that doesn't look like it. Did I recompile? Okay, so this is... Weird, didn't pick up any changes. Huh, what if I make it 10 times bigger? I think something is glitching with cargo because it doesn't really recompile. What if I do cargo? Well, I don't want to clean. Actually, let's try to clean. Is the k that alpha is 0? Yeah, this shouldn't really matter, but let's try. I think the problem is that for some reason the code is not recompiling. I don't know why. Like you see, there's like no compilation at all. So if I do something, if I break my code unintentionally, it shouldn't even bother. Weird. So you see it doesn't recompile for some reason. I'm not sure why. Let's try to clean and run. So did you write the music? Nope, that wasn't me. That was another person working on this project who is specifically a composer. I don't do music and I don't do animation. The only type of like artwork I do for this game is that I sometimes draw decorations. I can even probably show you which one I did myself. And actually it's already opened. And I also just mix other assets, but usually I don't really draw much myself. So this stuff, this is the stuff I draw. I also experimented a lot with generating different things just for like placeholders. So all these trees, they're not drawn by human, they generated, and then I just went through them and manually adjusted a couple of things. So that's why they look kind of ugly and blurry. In the next updates, we'll try to replace them. They all generated with like a plugin for a sprite. But some stuff like these bushes looking much better. Oh yeah, and I also drove this, thanks. But most of the time I just buy some assets on each, if there are any, and then maybe I modify it a little bit. So I bought these assets, and then I bought these assets, and then I tried to mix them together to make some different kinds of ore veins. And yeah, there were a lot of experiments I did with generating textures for planks. It looks kind of okay, but like when you try to actually put it in the game, it looks super ugly. So it didn't really go anywhere. Yeah, so this is only kind of stuff I do. Okay, let's see. Damn, still compiling. Okay, so let's wait a little bit until it finishes, and until then I can probably show. Actually, I have a version of a game that I compiled before. Let me just use that one for now. Wonder. Okay, so there are a couple of questions. Let me just try to go them and answer. About the Hellhound, when you say faction, is it just for enemy types, or can the player start as different faction? So players start as a human. I don't think there will be another faction, because they're just like a lot of work. But I think there will be other villages on the map with other humans, and maybe you can like trade or interact with them or do some quests for them. Actually, since I mentioned quests, let me get back to what's gonna be in the next updates. Oh shit, accidentally clicked on this thing. Anyway, so the next thing I was this is what I was planning to add in February, but actually I'm working on it now, because in February I was working on sound, and pathfinding is next one is construction system. So as you can see, oh my god, this Rust rover takes forever to run when something is compiling in the background. Is it done? Sorry. Okay, so this finally finished compiling. Let me see if there's anything changed. Oh yeah, now you can see. So that's what 100 intensity look like. Let me try it just out of curiosity how it's gonna look like in the cave. I don't know why wasn't the compiler picking up all the changes incrementally. So weird. But I see it sometimes on Windows. So yeah, we just basically spawn a light. Anyway, yeah, let me get back to the faction part. After I will go through all the things I plan in the next release, or in the next version. Cool. When you're walking around, there's a minor. Okay, so this is something I already answered. Okay, now I can hear you. I had Discord problem. You could have probably clean. Oh yeah, so that would definitely work. Thanks. You can just clean one package. Yeah, that would be faster. Anyway, so let me get back to the faction and the next updates. So first thing, after like in March, I hope to finish some construction system. Right now this is just basically a placeholder just to test how to put things in the world, but it's not really proper UI or proper system. So I'm thinking to like pick a couple of buildings, like let's say forge, and maybe housing, create assets for them, and instead of building using the multi-tool, you will be able to click on 5, and that will open the construction menu, and then you will build stuff. So yeah, hopefully we can have housing, maybe some wooden fences and forge assets for construction, and then there will be a proper menu and proper like a UI for that. Oh, and it crashed again. Yeah, so the next thing which my sound designer is suggesting, there will be sound spaces. Let me put it here. So the idea of sound spaces is pretty simple. So as of now, everything sounds kind of the same. But in a future version, there will be three types of space. You can be either inside of the house, or actually four, sorry. Inside of the house, in kind of like a field, in the forest, or in a cave. And based on that, where player is or player ears are, and where sound came from, we will have slightly different effect applied to the sound. Right now they just attenuate it a little bit based on distance, but we also will apply different, I think it's called convolution equalizer or something like that. Again, I'm not like an expert in how this works, but essentially this is, hopefully this will create a lot of atmosphere. So if when you go inside of the house, things inside will sound different from convolution reverb. So things inside will sound different from for the sounds that spawned inside of this house, comparing to how things will sound for the things spawned outside. And the idea will be pretty simple. We essentially it will work similar to how these roofs work, like inside of the engine. We'll try to if you know this tool in Photoshop, like that can fill all the color, what is called flat fill. We essentially will just flat fill the map and see how many types of different like walls we hit. If all the walls are kind of like constructed walls, then this is inside of the house. If it's if all the walls are cave, or most of them are cave, then we are inside of the cave. And otherwise we are outside in the field, and if we have a lot of if we're outside and we have a lot of trees around, then we will have like a forest sound space. So it seems like it should be relatively easy to code. Like I said, it will be similar to how this roofing system works, and hopefully this will add a lot of atmosphere. So yeah, if you're curious what we use for as a sound engine, it's built on top of Fmod, which is like super popular. Looks like the particle is completely broken for some reason. Cool. And the next thing we will have is role assignment. So I think I mentioned multiple times, this game is kind of like took a lot of inspiration from, let me restart, from RimWorld and Valheim, but unlike RimWorld, this is gonna be a lot more centered around characters. So as you see, we have this like number 4 slot, which will allow you to talk and interact with characters. So this is how you can assign to them what's their role. Should they be kind of like warriors, or blacksmith, or miner, or woodcutter. And sometimes you can talk to them, they can give you quests. They all gonna have like different names, and ideally at some point different like outfit and stuff like that. So the role assignment will be the first thing. You can click on this number 4, then kind of point to character and tell it, hey, you're now gonna be traveling with me because you're a warrior or something like that. Or you can talk to this guy and tell him like, hey, we need more woodcutters. So this is how you can, you can just like click or use some button somewhere to create all these assignments. You need to actually go and talk to your people. So hopefully this is gonna be fun. If it's not fun, if it's more like annoying, we will do something else. And utility AI. This is pretty simple. Right now, the only 2 things that, I think the only 2 or 3 jobs that characters can do, they can either navigate, or harvest resources. So this guy, he follows me, this is his only job. And these guys, they harvest resources or just do something stupid over there. Obviously, in the proper game, we would need more. We probably will start with like hauling and maybe some crafting for these guys, hunting for animals, and then maybe some kind of like defense AI that can basically attack everyone who's around. So those are the set of things we'll start. Maybe later we'll do, like indefinitely later, as we go, we'll add more and more of them. Cool, so let's see. Can you assign any role to any NPC, or are some better at woodcutting? Yeah, so this is ideally how it's gonna be. You should be able, at some point when this system properly working, you have some skills, and based on the skill of NPC, you can decide what it should do. The way NPC is gonna spawn in your colony will be more or less similar to how it's, at least the current idea is do it more or less similar to how it works in the real world. Every day you survive, they either will just join you from, you know, they will hear about your colony and like maybe travel and decide to live in your colony, or maybe you can find like a camp and either hire them or offer them to join your colony, something like that. Probably the first thing we'll try is to just spawn them every day. Should be pretty simple. And then, yeah, and then you can decide who will be doing what based on their skill set. Cool, this guy was cutting a tree or something and accidentally killed that mob. This, by the way, just double checking, how is this wood plank sound? I think it's really, really satisfying to collect these wood planks. What do you think? All right, cool. So let's go to the next part. I'm just gonna go into pathfinding and maybe like go through the shaders, which I didn't really do last time. So yeah, the way pathfinding works is pretty simple. We have a map which is split into, let me open it here. We have a map that's split into the chunks. I think currently they are 128 by 128. There is always an active chunk around the player, which is currently simulated, and there will be one around the colony. If you decide to travel far away from your colony always going to be in memory and simulated. So for every active chunk, we just scan through it and build a navigation grid on every frame. So everything you can see here, we scan through every entity on the map. We also look into every block of the terrain, and we build this navigation grid. So there's like no optimization, just rebuild from scratch every frame. The grid is regular, so you can see this little squares, and I can probably start looking into code how this exactly works. So we use regular grid. There's like no mesh, no like other types of sparse graphs or anything like that. And the way it's represented is where is it? Yeah, pathfinding. It's represented as a dense grid. So dense grid is just an array. Where is it? Which has some nodes. And every node is this little square. Hopefully you can see it through the compression. And the things that it has is just 8 bytes. It could be 1 byte, but for now, for simplicity, it's 8 bytes, and they encode what direction you can travel from each of these squares. So yeah, each direction is basically has like a position, for top, bottom, left, right, and all the diagonals. Is it I8? Oh yeah, so and it's signed. So if we need to decide, giving this direction where we can travel, we don't need to look into other elements of array. We just look into one element and it should encode every direction we can go. And then there are a couple of utility functions that can initialize this grid and put everything as default. Basically means you can go any direction. Then there are a couple of functions that allow us to add new nodes or remove nodes, get all the edges and all this kind of stuff. Super ugly, went through many iterations. We'll definitely clean it up at some point. And this is the A star. It's very simple A star. It's almost the same. If you know this crate called pet graph, this is a very similar implementation, just slightly simpler. We just have a list of visited. Sorry, we have a list of things to visit next. We have like some estimates and a tracker of the path we currently have, and then we just picking the next direction to visit. We trying to construct the path. Sorry, if it's a goal, then we construct the path to that from our tracker. Otherwise, we look into every direction, we estimate all the costs, and we place them into the heap. And then we decide which one next to go, I think. Something like that. Again, been a little bit a while since I wrote it, but it's very classic A star. The path tracker just array of visited nodes, and then we kind of like reversing it when we're reconstructing it. Yeah, and then I think that's it. As you can see, this is like 90% of what pathfinding does. So the way this is used, it's used in, so this like a dense grid is used inside of the navigation grid, which combines multiple layers. The two layers used now is terrain and obstacles. Terrain is where we store all these like grid structures, and obstacles is where we store information about these irregular structures. So on a couple of things we do here. This is just debugging. This is activating. Yeah, so I don't even know how much I need to explain here because it's pretty simple. The only basically the only thing it does, it goes through all the arrays of everything that marked as obstacles. It tries to figure out what space to mark as an obstacle based on the collider, and then it does basically the same thing for these grid structures. The reason why we have two grids is because we kind of like want to combine them together when we do pathfinding. Yeah, and then if you can imagine what this thing does, it's kind of like, builds. Imagine you are a train, and the pathfinding system builds rails for this train to navigate. So then the AI system, it will try to follow that path, but the AI has its own kind of like logic, how to move, how to avoid obstacles, or not, how to not avoid them, in my case, and stuff like that. Yeah, let's see. Wonder if anyone have any questions or anything I should clarify, but that's like at a very high level, very high overview of how this pathfinding works. So I guess I can show you where this is used. We have this AI system that has two levels. There is a job level, which has like a high level description of what you can do. And you can see all these jobs like attack, harvest, navigate, and we have a step layer. Where is it? And that only two steps: navigate and play animation. So if we look into something that, for example, harvesting, it has two steps. It has a navigation step from current position to the resource, and it has play animation step to collect that resource. And when we finish navigation, when we entering this play animation step, we need to equip harvesting gear. We need to set the aim for where to point our tool, and then we just play animation, and we stop on any of this condition when something we're trying to harvest is not found, or where if it's exited destination, I don't know, for some reason, or somebody else is already working on that. And the way navigation works, where that grid is used, something like this. So this is how navigation step works. So it checks if we currently have a path. If not, then we query A star and generate the path. As you see, all this things are drawn here, like all this green lines and all this stuff. And then we're just trying to see what's the closest segment of that path, and if we're too far from the beginning of the closest segment, we try to set the impulse to steer toward that segment, and if we're getting too close to it, then we kind of mark it as completed and we go to the next segment. So yeah, and if you look into this guy who follows me, as you see, as he completing the segments, they becoming kind of gray. So that's basically exactly what's happening here. And then the only thing that outputs is to forward direction for steering, which is then used in movement system, which also again so convoluted how it works, but it again went through a lot of iterations. The movement system is here. So the way movement system works, it just goes through every agent. It tries to get all this steering impulses, and it tries to do something very basic, collision avoidance, and then it basically computes the forward impulse based on where navigation system tells us to go and how we want to steer to avoid all the collisions. And also it tries to take into account formations, like if you go in a formation with other units, you will not really steer, so you don't really need to avoid them. You just go if you follow the same direction. Cool. Let's see. All right. So if nobody have any questions about navigation, I can try to. Oh wow, where this guy tries to go. I will try to show you how shaders work in a little bit more details than last time. Let's set some nice lighting scene over here, and let's maybe put a couple of torches just in case. And let's try to. Actually, it's not gonna. I don't think it's gonna work like that. Actually, let me try. I think we need to start from render doc. So, let's see. Let's close this one. By the way, question: did anyone use render doc before? All right. Looks like not a lot of people really active in the chat. Let's try to launch. I usually use Xcode shader debugger because I usually work on Mac, but I tried to stream from Mac a couple of times. It just works pretty bad. So I switched to Windows, which is 10 times better for all this kind of stuff. I don't really use RenderDoc, but it's more or less the same as shader debugger. I also tried to install Nside, but for some reason it just doesn't work. I don't know. It installs something else. It never appears in this search, and I just gave up for today. So I'm gonna be using RenderDoc. So we just launched the application. You can see to capture, you just do F12 for print screen. Yeah, let's set up a seat. Like let's set up like some nice lighting, just so we have like some variation. And maybe let's set it to kind of like a darker mood. Maybe like one more. Cool. Now let's open it full screen and do F12. And this should, and nothing happened. Print screen to capture, 0 saved. Okay, I definitely did it before this stream. Let me try a couple of more. Okay, something happened. That's good. Let's go back. All right, looks like it captured. Okay. Cool. All right, so we have a capture. Looks like it figured out the right API and all this kind of stuff. And let's just go again step by step how we are doing lighting. As a reference, this is a really good paper that I tried to recreate. Of course, it's like the thing I'm doing in the game is like 20 times simpler than here. But essentially the idea is the following. You have two captures that you can use, oh sorry, you have like two components that you're using. This is like a little bit too loud. Just mute it a little bit. So there are like two components that you use. There is the screen space global illumination, is a world space global illumination. I'm only doing screen space right now. So the idea is like you split your screen into many grid cells. They use 8x8. I think that's what I also do in the game. And then you basically pick a point inside of each cell, and you do it randomly with like a specific algorithm, and I can show you exactly which one. It's called Halton. Yeah, so this is what you use. Essentially, it's gonna give you like nice, almost like random, but not fully random distribution. So imagine like this is your cell in the grid, and every frame you're picking one of these points to where to sample light. And as you can see, they're not like clumped, they more or less uniformly distribute, but they're still random. So this is what you do in every frame. You pick a random point to sample, and then you do it for your current frame, and then you also remember 8 previous frames. So if I go to if I go here, and if I try to find these things, as you can see, and hopefully I can zoom in. So this is what we do. Every frame we pick one of this atlas, like we pick one of these tiles from the atlas, and come on. Okay, so this is not what I'm looking for. Okay. How do I zoom? Feet, 200%. Cool. I think this might not be it. Let me just double check. Or maybe that's it. So let's see. This looks like a SDF to me. And one of this is, okay, let's say this is the one. So as you can see, there are like 8 tiles on this atlas, one for each frame. So basically, on every we pass a counter for the frame into our shader, and we compute offset for our current atlas based on the frame, and then we know the world position of our current pixel. We try to jitter it a little bit. Actually, let me go back to the code now. Maybe that would be easier to illustrate if I show both. And by the way, please ask questions if something is hard to follow. I'm not the best explainer because I also don't know this that well. So probe is the first one. So we set up our shader to have, and let me show you where we also set this up. We go to renderer, jar renderer, GI. I think it's in the mode. So first we do SDF, which I don't really need to explain. I think SDF is pretty simple. It's just distance to closed obstacle. The second one is the shader for lighting probe pass. So we take the size we take the size of our screen, and then we split it into the workgroup, which is 8, and the grid size for this, let me see where it's calculated. So this is just the screen size divided by number of by the probe size, which is 4. So I guess, yeah, each of the styles here is 4 by 4 in our game. So when we set up the shader, we use this workgroup size, and this is the size of the grid that we send to the shader, sorry, that we dispatch. So then inside of the shader, what we do, inside of the shader, based on the current index, we try to figure out what's our world coordinates, and then we also try to figure out what of this probes we're currently looking at. So this is pretty straightforward. Then we do all this kind of like offset calculation based on current probe and current atlas, which is also current frame. Oh, that's really cool. Thank you. And what we do here, once we do all that, we figure the offsets, then we add a little bit of jitter, which is kind of like this algorithm. Let me see, just to give you a good explanation of what is this. Yeah, so basically this is, I think this algorithm is essentially one of the ways to produce this sequence. So this is what we use, and then we multiply it by the probe size to collect jitter within the probe. Then we get our coordinates with offset to this atlas. We convert it to what is it? I don't know why we do that. I think this is just to do some checking. We check if it's masked. It's only masked if we are under skylight mask, which is basically all those roofs. If it's masked, we kind of like we set it to 0, and then we're gonna use it later to multiply and cut all the masked light. What else we do? Then we sample SDF. Then we do we go through every light source. We check if they within the distance. We cast a ray from current position to the light source to see if it's blocked or not, and that's what we basically use SDF for. Then we sample fog density, and then we get the distance, and then we compute attenuation based on a bunch of stuff, and yeah, and then we add it to the irradiance, and after that we let's see, and then we calculate where in this atlas we're going to store the result, and then we just store the result in the atlas. And the way we calculate it, we compute this row and column based on current frame, and then within this atlas tile, we also compute the position, and we also pack in the same float. We pack in the same let me see. So we store irradiance, and we also store in the float how much jitter we have, and the jitter is 2 F32 coordinates, but we convert into F16 and then pack together into one float, so that way we can store both color and jitter in the same vec4. Hopefully that makes sense. So then we're gonna get this output where position encodes the position in the world and frame, RGB encodes the color, and alpha encodes the jitter of the specific probe. And then we can completely reconstruct where exactly this probe was sampled from in the next step. So the next step is to for us, for them it's like something else, but for us the next step is to combine 8 previous frames. Sorry, actually no. For us the next step is to let's see what it is. Maybe I'm mixing something up. I think the next step is to, let me go back to my pipeline, bounce. So the next step is to sample, essentially we want to now get, so the previous step gave us direct light, and the next step will give us indirect light. Let me find where it is. So the indirect light should have a lot more brightness than the direct light. Unfortunately, it doesn't really show me the labels for this stuff, so I don't really know how to tell which one is which. But I guess this one is indirect because this is brighter. Indirect one is pretty simple. We just we start from sampling the color for our current probe from the previous step, and then we just go to basically do this exponential sampling around that probe. So we generate some angle, and then we generate some radius, and we kind of like doing this like a circular shape to send a lot of rays. Again, check which of them intersected with any obstacle, and then we accumulate them and also take into account fog and other stuff. And that will give us sort of like indirect light. It's obviously not the correct way to do that, but it's better than, you know, not doing that. Cool. And this will essentially do, let me show you how this can look in the game. So if I turn on my lighting plugin config, you should be able to see a big difference. So I think this is Ready magic light 2D. Okay, so now if I run it with this config, you should be able to see a difference between direct light and indirect light. Let me just quickly look a little bit more into the code, making sure I don't miss anything. So we get the probe, we initialize indirect radiance, then we just doing some steps for radius, we construct some angles, we go through and then we construct a bunch of rays, and we just sample. That should be pretty simple. Alright, I'm not sure why it takes so long to run. Weird. What's next? The next thing is to let's see. Is to blend. So the blend part is where we go and actually assemble the final light from all this like 8 frames. And the way this should look like in texture is basically the same but doesn't have atlas. It's like it's already like kind of like one reconstructed image. Okay, let me first show you the difference between direct and indirect light here. Oh shit, this is weird. Let me just make it darker, maybe place some torch. So if I just do the direct, I should say to 1, and I should set this one to 0. Let's see. And let me make it actually a day, because during the day we don't really have any fog, so that might be easier to. Actually, I don't know. Maybe it's not like really that noticeable. Let me see. So as you can see, this shadows are more sharp. And if I do it the other way, if I set this to 0 and this one to 9, as you see, they kind of like a lot more blurred and a lot more, yeah, a lot more blurred and a lot more noisy. So also, let's say here, as you can see, since there is like no indirect light, this is pure black, because the light comes from here, and it only touches this part, and it kind of attenuates. But if I add indirect light, you can see it now can kind of like go bounce from here and like eliminate a little bit of stuff over here. So this is the difference. And the way it's done is pretty simple. We, like I said, let me just show it here. So let's say we want to figure out how much light we have in this point. We just start sampling exponentially all the light around computed from the previous step, and then we gather everything and attenuate again. So yeah, this is what essentially this blend, this bounce step does. Hopefully that's kind of sort of clear how it works. Damn, this is really strong light. How does it work? Anyway, but yeah, it adds a lot of cool kind of like aesthetics. Yeah, so the next one is we just go through 8 of those frames and then we assemble one from them. This one is a little bit more nuanced, so it's called blend. So we're only blending 8 frames together. The way this one works, we go through 8 previous frames. We know where we start. We go through 8 previous frames. We figure out the prop ID based on the current index. then we get the camera offset for that frame, and then we figure out how much camera moved from that frame to the current frame. So that way we know where exactly to sample that frame. Because if we move camera a little bit, we can't sample from the same position. We need to move the sample position according to the camera change in that frame. Then we grab value according to that change. So the way this part works, and hopefully the way this part works, we essentially just call like very simple reprojection, except it doesn't take into account scale, angle. It just only take into account translation between current position and that frame position. So yeah, we calculate all these reprojections. Then we just get the probe from which to sample. We do some basic check, which I think has a bug. That flickering around the screen is because we're sampling from incorrect place. And then what we do, we apply this filter. We apply this filter for to kind of like figure out how much that value should affect our current color. And why do we do that? Because the position of that probe might be like, depending on how far it is from the current sample, it should take, it should kind of like be less, the further it is, the less important it is. And I think the second part is also calculate the, oh, hold on, sorry. Maybe I'm doing something stupid. Compute the light filter with Gauss function, but why do we do that? I guess we're just doing it based on the position. We don't really take into account color difference. So I guess this is done to make sure the probes that further away from current sample are less taken into account. And then we calculate it by that color stored on that probe, and then we just do some clamping and return. And then here, we just sum them up together with weight. And how do we do this weight calculation? Total Q. So the weight is just, yeah, the weight is just position based. Okay, so the further away, the less weight it has at the end. Okay, so that makes sense. What's the next step? The next step is, and as you can see, the way this should look. Again, let me double check that we're looking at the correct texture here. So I think weird. Okay, I don't know if this is the correct order, but I think this one is the correct texture. Again, unfortunately, for some reason it doesn't show me the labels for this commands. Inputs and outputs. Weird. Anyway, what's the next step? The next step we just blur, as far as I remember. Blend and filter. So the filter is just blurring. And the way this works is pretty simple. And let me show you how does it work without the blur. Actually, let me turn off render dock. It's not really important anymore. And then let me just run the game and show you how noisy this will be without the blur. Oh, actually, let me just play with a couple other things, and let's turn off this thing in the combat because this is very distracting. Or can I just use here audio debug? Weird. Anyway, combat system. Let's do it. Let's roll back this change. And it's stuck. Okay. Cool. The thing I wanted to show you is just I just wanted to play with a couple of parameters for the lighting and show you how this affects the result picture. By the way, just double checking, you can still hear me, right? Okay. Cool. Yeah, let's make it dark again. Let's well, let's make it bright, and let's go to the cave because this is probably the best place for lighting demonstration. And let's put a torch over here, and our character over here, and then let's open a shader code, and let's go to the bounce part. Again, I don't know if it's going to be that dramatic difference, but let's just so this is, let's start with number of lights, so number of rays to samples. So this is should be like more accurate as we add more and more samples. So now it's doing 256 for every layer. I don't know if it does much. I think after some time it's probably not a huge difference. Let's do it really small. What about 1? So this will just do 1 ray per radius. So it will go through multiple steps to sample indirect light and only send 1 ray per each radius. So this is 2. So I guess after like some number it starts to converge. Yeah. And this is how much we increase the radius on every step. What if we do this? This is how many, this doesn't work. This is how many frames we accumulated. So if we have 16, it will take into account 16 previous frames. I don't think it's gonna be that much difference unless you have like some really fast moving lights, which we don't have here, but essentially it kind of like give you more accurate lighting because it can use more information and more jittery samples, but it's if you don't have, but it also kind of like will leave a traces if you have a lot of dynamic lights. And if you have 1, it's very jittery because now basically imagine like every frame we're sampling from slightly different point and we don't have any history, and then if I add more and more it should be more and more stable. Oh my god, these particles are completely broken. Yeah. So now let's look into stuff without filtering. So as far as I remember, it was like super. Oh, actually, we can just simply turn it off here. So this will produce very pixelated, or at least it should produce very pixelated results. Oh, we lost all of our stuff. I don't know if you can see it through YouTube compression, or sorry, not YouTube, Discord compression, but this is now a lot more pixelated. Again, it might not be a bad idea because this is a pixel art game in the end, and this is gonna be a lot more smooth. Actually, you know what? Let me try to rerun it with a lot bigger a lot bigger probe size, because the thing with probe size 4x4, it's not really noticeable. Let me try 8x8. Let's turn this off. So if I have 8x8 and if I turn off filtering, essentially if I make this kernel 0 size, then it should be super pixelated. Let's see. Yeah, so you see this now looks very ugly. This is without filtering. So essentially, now we only have this 8x8, 8x8 probes. We don't and then we don't really try to smooth them. But if I try to smooth it, should look a little bit better. And what if I do it even more? Cool. And filtering doesn't really add that much. And the last part is like, I think, which adds a lot of, it's not part of the lighting. It's kind of just like a post-processing. So the things we do here are we convert it to the same color space, and then we apply that calculate light differently based on the layer. Now let me show you a couple of things first. So if we don't do any color space translation, this is what we get. So this is like a this is light from linear space without sRGB conversion. So you see, it's like everything is really dark. This is the first step. The second step is like when we apply different logic based on the layer. And let me again show you how this works with and without. So object irradiance. This is pretty important one. So let's see, we have this object here, which are, you know, dudes. And they kind of look like, as you can see, they are much more bright than terrain and walls and all this kind of stuff. And this is because of this loop. If I turn this off, this is by default how the lighting looks like. So it kind of looks weird. So what we do here, we sample the color from object layer, and then we sample everything around it with this kernel. We go, it's like a 3x3 kernel, and we kind of like do 28 on every iteration, and we do 28 increment on every iteration. So we go through this kernel and we accumulate the light around this object, and if we found some light, we add it to the object. It kind of doesn't make a lot of sense when I say it like that, but essentially that it makes objects get the maximum of everything around them in terms of light. So instead of maximum, I can also just do accumulation, and then that will make them much brighter. Let's see what it's gonna do. Yeah, so this is gonna highlight everything, because now the gathering just all the light around. Instead of that, we can also do that and then average, and this will make objects kind of like, oh, I wonder if it's gonna work. So yeah, now they kind of get the average around them, which also looks not bad. Actually, I kind of like the way it looks. Maybe we should do it with some, with some kind of like a coefficient. What if we do 0.4? Yeah, so this also looks pretty cool. So instead of maximum, we can also try average. So this is completely like non-physically based way of just making things appear, objects appear a little bit different from terrain. Yeah, and there's a lot of stuff like that in the game, like the whole thing, how we do like all this like combining fog and light is also basically very artistic. It's not based on any physics. Cool. So yeah, I wonder if should explain anything else, or if this kind of like where we should stop this stream. Wonder if anyone have any questions or suggestions for the next streams, or something I can explain before we wrap up. Will it be easy to expand? No, it will be really hard, I think. 2D is like dramatically simpler. Like everything is so much simpler in 2D. You don't really have a lot of problems like disocclusion, like because you don't really have that much objects on top of other objects where, you know, disocclusion matters because in every frame, we look into previous 8 frames when we try to gather what was the light that came from that surface. So if you have this occlusion, then it means something could block that light, and we need to somehow account for that. In 2D, this is much more rare, especially if you always have like different layers and all this kind of stuff. In 3D, this is a lot more difficult. Also, the reprojection is super cheap and simple in 2D. If you remember, all we were doing, we were just moving, we were just taking into account how much camera changed. We didn't care about the angle, we didn't care about like rotation or zoom. So in 3D that would be a lot more complex and probably a lot more noisy as a result. Because yeah, as you can see, there's just not a lot of stuff changed between frames. We just like added some pixels over here, we removed some pixels over there. But overall, we can always just go to the previous frame and figure out how much light we how much light we was on each surface in the previous frame. In 3D, that would be just a lot more difficult. I'm pretty sure a lot of other tricks I'm doing here for 2D just because it looks okay. In 3D, it would look like garbage. Speaking of garbage, there is a lot of other stuff that doesn't, oh my god, still have this bug where when your character spawns, it doesn't really have any inventory. So every time you pick something new, the inventory kind of resets. So speaking of garbage, the next thing I will probably do is at some point is like make pixel art rendering better. Right now, it's kind of like, I don't know if you can tell, but we don't have like a pixel perfect camera, so everything kind of jitters a little bit when we move. That would be really good to fix at some point. I just didn't really have time for that lately. Cool. All right. I guess if this is all the questions, thank you everyone for joining, and hopefully we'll do next stream in about a month. And like I said, here's the plan for the next stream. Construction system, sound spaces, role assignment, and utility AI. Hopefully when this is done, we will just need to add saves, some basic menu, and that will be enough for for the playtest. In the playtest, you should be able to build your colony, survive some waves, and assign roles to your characters, and maybe like do some basic interaction and crafting. Cool. All right. Thanks, everyone. And we'll see you next time. Bye.